In early 2010, Veris introduced the OpticMapper, an on-the-go soil sensor that maps variations in organic matter. This new sensor is mounted on the Veris mobile sensor platform, so you can map EC and OM at the same time. The result? The precision and full field coverage that only on-the-go sensing can provide for EC and OM. In this video, we'll try to answer the question, does a map of organic matter matter? Should it matter to you? On most fields, areas that are higher in organic matter have had increased productivity in the past. That increased biomass has led to more organic matter being present. Take this field for example. The area we're standing in has organic matter in about the 2% range. As you can tell from the heavy wheat stubble, and my yield maps show the same story, this area of the field has much higher productivity than the area up the slope that has lower organic matter. Here we are in the lower organic matter part of this field. The stubble is shorter, there's just been less productivity here. Now the organic matter levels on this field from 1.5% to 2% are typical for central Kansas. The organic matter levels on your fields may range from 0.5% to 1% or from 3% to 6%. But regardless of what they are, chances are very good that productivity will differ from your low to your high organic matter areas. An organic matter map shows where a field has produced in the past. It's like having 100 or even 1,000 years worth of yield data. But that increased organic matter continues to drive productivity now, with better soil structure, nutrient cycling, water infiltration, cation exchange capacity. Those factors drive productivity in the future as well. If you can apply organic matter to a field, such as with manuring, a Veris OM map will show precisely where those applications will do the most good. If you're setting up zones based on productive potential for inputs such as nitrogen or seed population, a Veris organic matter map matters.
So if what you've heard so far matters to you, let's take a look at the OpticMapper equipment. Here's how it works. We have the optic shoe running in between the double discs on a planter row unit, and we're shining light through a sapphire window. Dark soil is going to be higher in organic matter, and obviously light soil is going to be lower in organic matter. The sapphire window is a very durable material, second only to diamonds in wear characteristics, and we're running that down below the surface of the soil, so depth control is very critical. Maintaining a consistent depth on the OpticMapper is as important as it is on a planter, and here's why. Soil moisture varies a lot near the surface. There's lighter colored, drier soil at the surface and darker, more moist soil down below. If the optical device is bouncing around in the soil or is obstructed by residue or surface drying effects, the map can be fooled into thinking that dark soil is higher in organic matter when in reality it's wetter. When measurements are in the soil and the depth is consistent, those moisture effects are not a problem. So what wears out? As with any planter row unit, you are going to have maintenance items like the blades, bearings, tires, and so on. But unlike a planter, we're only looking at one row unit. And you'll have the expense of the wear plate with sapphire window, which is a replacement part. You can expect about 25 cents an acre operating costs for the planter and the optic components.